Welcome to mathematics. My name is Semangia, the Maths Ego. Right. So on this topic, it's all about probability. Probability is one of the key or the main topics in mathematics, right? So just be following up carefully as the ego will be explaining their key concept based on this topic. Right, so you can see my digits, everything, my name is there on your screen, right? So let's go deeper with probability. So the first thing basically is on defining what is probability. Right, so by definition, probability is the chance of an event occurring. That's what is known as probability. So the probability of a certain event is the chance of that event occurring or happening. That's what defines its probability. If I can write here, the probability is the chance of an event occurring. Is the chance of an event occurring or happening. So how likely is the event to occur? That defines its probability. Then probability, it ranges from 0 to 1. So it lies between 0 to 1. That's probability. From 0 to 1. What does 0 means and 1 means? 0 means that you are certainly sure that the event will not occur. That's what 0 means. So the probability of something being 0 means that you are sure that that thing or event will certainly not occur. For example, the probability that a boy can get pregnant. Wow. What's the probability? It's actually 0 because a boy will never get pregnant. So the probability is actually 0. Then 1 means you are certainly sure that the event or something will certainly happen or certainly occur. That's a probability of 1. So what can be an example of that one? Right, an example, the probability that it will rain on any day of the year. You don't know which day of the month, but you are sure that one day it will rain on that given year. So the probability of raining on any day of the year is actually 1. What? So 0 and 1, that's the probability, which means probability, if it's between 0 and 1, it means it will never be negative. 2, it can be expressed as a percentage or as a fraction, which means that we can say 25% probability. This one can be the same as 1/4, can be the same as 0.25. So you can express in whichever form, as a percentage or as a fraction or as a decimal. But as long as that number or value will be between 0 and 1, it will never be more than 1 or less than 0. That's probability. Right, then application of probability. Where are we, or when are we supposed or going to apply the concept of probability? That's the application of probability. Right, 1, probability can be applied in coins. Right, a coin has 2 sides. We have a head and a tail. A head H and a tail represented by T. So these are the 2 sides of the coin. So it's either a head or a coin. Right, on these coins we have about 4 different scenarios or dimensions. First, we have a coin just tossed once. What will happen? How many possible outcomes will be there if a coin is tossed once? Right, so you have a coin tossed once, but before that, let me give you the formula for calculating probability. Probability required is equals to number of required outcomes number of required outcomes over number of all possible outcomes. Number of all possible outcomes. Yes, so that's the probability required. Formula for finding or calculating any probability required. So it's the number of required outcomes, that is, and over the number of all possible outcomes. Right, let's continue with these coins. So on coins, first scenario, on coins, a coin tossed once. A coin tossed once. If a coin has just been tossed once, what will be the likely outcome? How many possible outcomes will be available if a coin is tossed once, right? There are two possible outcomes. It's either you get a head or you get a tail. So there are two possible outcomes. Then the probability of throwing a head or getting a head, it will be, you say, based on our formula here, probability required, number of required outcomes over the number of all possible outcomes. How many possible outcomes? In other words, how many heads are there on the coin? It's just one head over the number of sides on the coin. That defines the number of all possible outcomes, which is 2. So there are two possible outcomes on a coin. So probability of getting a head will be 1 over 2, which means 1/2. You can also say 0.5 is still the same, or 50% is still the same, but just use half. That one is better that way. Then even a tail, probability of picking, of throwing or tossing a coin in this case, it will still be 1 over 2. Then another scenario is a coin tossed twice. A coin tossed twice or 2 times. This one can be equivalent to 2 coins tossed at the same time. 2 coins tossed at the same time. At the same time. Right, in this scenario, how many possible outcomes do we have? Right, it's either on the first toss, you can get a head, and tossing the second time, you can get another head. Or you can get a head and on the second a tail, or instead on the first you can get a tail and on the second you can get another tail. Or you can get a tail on the first followed by a head on the second. So there will be 4 possible outcomes. 4 possible outcomes altogether. Then if I'm being asked, for example, the probability of 2 heads, probability of getting 2 heads, it will be equal to, you just count how many of these outcomes do we have 2 heads together. It's only the first one. It's this one. That's where you can have. So it's 1 outcome out of 4. So probability of 2 heads will be 1 over 4, which is 1/4. Right. Then if I can say probability of at least a head. At least a head. So it just, at least means greater than or equal to 1 head. Right. So how many points or possible outcomes? We have 1, 2, 3. So it will be 3 over 4. So those are that will be the probability based on this. Then number 3, part C, a coin tossed 3 times. A coin tossed 3 times. 3 times. Right, so this one is equivalent or the same as 3 coins tossed at the same time. So how many possible outcomes will be there in such a scenario? It's either on the first you get a head, followed by a head on the second, followed by a head on the third. Or you get a head on the first, followed by a head and a tail. Or you can get a head, tail, tail, or you can get tail, 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 or you can get tail, tail, head, or you can get tail, head, head, or you can get tail, head, tail, or you can get head, tail, head. So these are the possible outcomes. How many outcomes do we have? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 possible outcomes altogether if a coin has been tossed 3 times or 3 coins have been tossed at the same time. There are 3 possible outcomes. Then if I'm asked to calculate the probability of maybe getting exactly 2 tails, exactly 2 tails, 2 tails, probability of getting exactly 2 tails, what will be the probability? It will be, you find out where there are exactly 2 tails. On these outcomes, we have 1, 2 tails, we have 2, 2 tails, and we have 3. And this one, so it will be 3 over 8. Then you are done. So that's the probability of getting exactly 2 tails, right? Then application of probability in the second application is on playing cards. Playing cards. That's another application of probability. How can we apply probability on playing cards? Right. So first you have to know how many cards are in that pack of playing cards. There are actually 54, but mathematically they will say there are 52 cards. Why? Because we don't want the jokers. So joker will remove, there are 2 of them. So you remove the 2, then we'll be left with 52 cards in total. So there are 52 playing cards in total. Let me write it here. So there are 52 cards. 52 cards. Of these 52 cards, there are 26 red cards and 26 black cards. And they're divided half, the red and the black. Then on these 26 red, they are also divided into 2 parts. We have what are known as hearts. So there are 13 hearts, 13 hearts, and 13 diamonds. 13 diamonds. Then on these 24 black cards, they are also divided into 2. We have 13 shrubs, and 13 spades. And 13 spades. So 13 shrubs and 13 spades. Then on all these cards, we have an A, usually called an S. We have 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have J, K, Q, like this. So how many cards do we have altogether? There will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 in total, which means on A there are 4 A's. 1 A for the hearts, 1 for the diamonds, 1 for the shrubs, and 1 A for the spades. Even on 2, there are also 2 4s. So all these cards, there are 4, 4, 4, 4 of each. 4, 4, 4, 4, 4 sevens, 4 8, 4 9, 4 10, 4 jack, 4 K king, then 4 queen. So to make them 52 in total altogether. Right. Then if based on this one, if a card is picked at random from a pack of 52 playing cards, what is the probability of picking a red card? You can just look here. How many red cards do we have? We have 26 red cards over the total number of all possible outcomes. That is the total number of cards. In this case, it will be 26 over 52. What do you get? It will be 1/2, right? So that's application of probability on playing cards. So on these playing cards, just have to know how many cards are in a pack, then the divisions based on those cards, right? We have black cards, we have red cards. How many are there of each? Then we have also on the red cards, which cards do we have? Diamonds and hearts. And on the black card, the shrubs and spades. That's what we just have to know and understand. Then the last application of probability is application on dice. That is number 3, dice. Dice, if it's one die, then plural is dice, right? Two or more dice. Right, this one, if a die, how many sides does a die have? Because you have two scenarios here. A, we have a die thrown once. A die thrown once. How many possible outcomes do we have? So the possible outcomes here are based on the number of sides that are on a die. So a die is a cube. So a cube, how many sides? 6 sides. So these 6 sides are labeled 1, 2, 3, 4, 5, 6. So that's how these sides are labeled. So it's 1, 2, 3, 4, 5 up to 6. Why? So if a die is thrown once, what's the probability of getting a 3? It will be, how many 3s are here? It's only 1. So it will be 1 over 6. Very simple. Then if I can say probability of getting an odd number, probability of getting an odd number, it will be, how many odd numbers do we have here? We have 1, we have 3, we have 5. So there are 3 in total, 3 over 6, which is equals to half. So you have to know what is an odd number. A number which, when divided by 2, leaves a remainder of 1. That's what is known as an odd number. Please take note of that. Take note of that. Right, so we are done on this part. Then the second part, part B on dice. A die thrown twice. A die thrown twice. Or this one can be 2 dice thrown at the same time. 2 dice thrown at the same time. So the possible outcomes are the same. When a die is thrown twice or 2 dice are thrown at the same time, how many possible outcomes will be here? Right, this one, it now depends, because there are different outcomes. It's either we want the total of the scores or the sum of the scores, or we can want the product of the scores, or we can want the difference of the scores. So it depends on what is being asked on the question. As on this example, let's work with the sum of the scores. Sum of the scores. So on that one, you draw what is known as the probability space diagram. The probability space diagram. How can you draw it? You draw it like this. So on this part, we have the first throw or first die. Then this one will be the second throw or second die. Second throw if it's 1 die. If there are 2 dice, it will be the first die and the second die. Please take note of that. Then a die has how many sides? It has 6 sides. Say label 1, 2, 3, 4, 5, 6 sides like this. Then also this other side, it will still have 6 sides. 1, 2, 3, 4, 5, 6 like this. Right. So if it's the sum of the scores, what do? You just add the scores. So it's either, for example, if you can get a 1 on the first throw and a 1 on the second throw, it will be 1 on the first plus a 1 on the second. Total will be 2. That's on this first part. So it will be 2 here. Or you can get a 2 on the first and a 1 on the second. Total, it will be 2 plus 1. It will be 3. Or you can get a 3 on the first and a 1 on the second. 3 plus 1, it will be 4. Or a 4 and a 1, total will be 5. Here will be 6, will be 7. Right, it's actually easy. Then on this one, 1 plus 2 is 3. 2 plus 2, 4. 3 plus 2, it's actually 5, 6, 7, and 8. Then on this one, 1 plus 3, 4. 2 plus 3, 5, 6, 7, 8, and 9. Then here it will be 5, 6, 7, 8, 9, and 10. On this one, it will be 6, 7, 8, 9, 10, and 11. On this one, it will be 7, 8, 9, 10, 11, and 12. So these are the possible outcomes in red. These are all the possible outcomes if a die is thrown twice or two dice are thrown at the same time. So how many are they? You just count them. 1, 2, 3, 4, 5, 6. Then times 1, 2, 3, 4, 5, 6. Going down. So 6 by 6. So there are 36 possible outcomes altogether. There are 36 possible outcomes altogether. Please take note of that. So 36 outcomes. Right. If I am being asked, for example, if a die is thrown twice, calculate the probability that the sum of the scores is 7. Calculate the probability that the sum of the scores is 7. So probability that sum of the scores is 7. So just count how many 7s do we have here. How many 7s do we have? So these are the 7 that we have. So count how many 7s do we have. 1, 2, 3, 4, 5, 6. So it will be 6 7s over total number of outcomes altogether. How many are they? They are actually 36. So 6 over 36. Then please, you have to simplify it to its simplest forms. So 6 over 36, it will be 1 over 6. That will be the final answer. So it's 1 over 6. Right. Then if you are asked maybe to calculate the probability that the sum of the scores is 10. Is 10, you just calculate how many 10s, count how many 10s are here. 1, 2, 3 10s. So it will be 3 over 36. You simplify, it will be 1 over 12. It will be 1 over 12. Right, so this one is the introduction on probability. Please, after watching this video, don't forget to like the video, subscribe the video, right, share the video. Thank you. So the second part of probability is coming based on the examples. We have examples, and you also have the probability tree diagrams. How do you use probability tree diagrams for you to be able to solve or to work out some complex questions? Right, so for this one, I say goodbye.